Hello everyone and welcome to my presentation. My name is Paria Torkaman and I'm a PhD student at the Norman B. Kevel Institute of Mining Engineering at the University of British Columbia. And today I want to talk about an innovative solution for eliminating mercury in gold leaching process. This slide is a brief background about me. My research is mainly about developing new practical and economical techniques for artisanal mining sector to convince them to stop using mercury. One of these methods is using cyanogenic plants as a gold leaching solution. Yes, you heard plants, and I will discuss this in a few minutes. But first, let me define properly what is artisanal mining and what are the environmental problems associated with artisanal mining activities. There are many possible variables that come to consideration to have an exact definition for this economic sector, but I have to say that all low-tech manual operations without having a long-term mining plan from individual planners to larger groups with the purpose of poverty survival could be classified as artisanal mining sector. There are about 40 million artisanal miners around the world that specifically 16 millions of them are gold miners in 70 developing countries. They use elemental mercury for the purpose of gold extraction and they produce 350 to 450 tons of gold per year. The Global Mercury Assessment in 2018 reported that around 2,000 tons of mercury are annually released to the environment by these artisanal miners, which represents the world's largest source of anthropogenic mercury pollution. In addition to that, the recent high price of gold, together with the coronavirus outbreak and elevating unemployment rates in developing countries, is pushing millions of people to do informal gold mining. This boom in artisanal mining activities will definitely increase mercury use and sadly increase mercury pollution as well. What happens in this process is that released mercury converted to methylmercury by bacteria in the environment and people get intoxicated by eating fish or inhalation of the mercury vapor, which contributes to harmful effects on nervous, digestive, and immune system, and also it can be fatal too. Nowadays, mercury contaminated tailings are being leached with cyanide in processing centers of artisanal mining and forming mercury cyanide complexes that exacerbate the bioaccumulation of the pollutant in the aquatic biota. Over the past decade, other lixiviants have been introduced to substitute mercury and cyanide in artisanal gold mining, but most of them either require trained operators or they are expensive for these impoverished people. At this point, cyanide is the only feasible alternative for artisans in developing countries to replace mercury. Cyanide, in contrast to mercury, is not persistent in the environment, and natural physical, chemical, and biological process transform cyanide into other less toxic chemicals. Many plants out there contain glucosides that can be converted to cyanide by hydrolysis, like bamboo, lima beans, cassava, that you can see in this table. Cassava is a local South American plant extensively cultivated as an annual crop in tropical and subtropical regions. It is known as a multi-purpose crop in developing countries. According to FDA, cyanide content in cassava can reach up to 1500 milligrams per kilogram in bitter varieties. Tasting the tip of the plant root reveals the bitterness and predicts the cultivator's glucoside levels. So, the more bitter the root is, the higher amount of cyanogenic glucosides the plant has. And based on what I mentioned about cassava, we chose this plant for our research. The enzymatic reaction of cassava that generates free cyanide is based on the hydrolysis of the linamarin, the main cyanogenic glucoside in bitter cassava. When the cassava root is crushed, the hydrolysis process starts and contributes to generating of HCN. On the other hand, in the leaching process with cyanide, when the gold particles exposed to the free cyanide, they are liberated from the earth. We use cassava solution as a source of cyanide in this process. One point I have to mention here is that in order to prevent losing cyanide in this process as a HCN gas, we need to keep the pH in alkaline range and ideally at 10.5. In the lab, the cassava root was crushed and squeezed to get the juice out. Crushing the plant cell starts the hydrolysis process, followed by generating free cyanide. After obtaining the liquid, then we investigated to see how much free cyanide we have in this specific variety of cassava. We used 3 methods to find the amount of free cyanide in our cassava juice, and you can see the results in this table, which are pretty much consistent. The next phase is the leaching process. For all of our leaching tests, we used a Colombian ore with 49 grams of gold per ton, and we did many leaching tests with different combinations of ore and leaching solution, which is here is cassava solution, that all of them have the same steps as shown in this slide. We to change the pH to 10.5 and keep it at that range, we use sodium hydroxide solution, and we shaked our different samples with different combinations of gold ore and cassava solution for the desired times with the shaker. And as I mentioned before, we check frequently to have our pH in the alkaline range. The next 2 slides show results that we obtained from our leaching tests. In this one, we have the combination of 10 grams of ore with 25 milliliters of cassava, and in this one, we have 10 grams of ore plus 40 milliliters of cassava solution. And from our series of tests, I can conclude that our cassava juice has 270 ppm of free cyanide that can extract 50% of gold in less than 24 hours, which is really promising. And based on these promising results, we are modifying and developing more lab tests to increase our gold recovery. Also, we are actively in search for cassava varieties with higher amount of cyanide, and also we definitely will try other cyanogenic plants. And our final phase of this research is to implement our modified process in the real field of artisanal mining, probably in Colombia. This study is an innovative strategy that can make a positive impact on all aspects of artisanal gold mining communities, like health, environmental, social, and also economical, by substituting a renewable abundant resource like cassava extracts for the highly toxic and environmentally persistent mercury. Thanks for your time and attention.